Ladies and gentlemen, we continue from where we left off the last time, testing of the controller. I would like to repeat what I did previously, and that is the testing of the controller. Well, this time I would like to make something in the form of what you call relative movement. And to make relative movement, I just check this box. I already have the 24 steps, and I release it, then click to have 0 position, and if I click, moves again, moves again, moves again, moves again, and moves again. If I want to turn the shafts in the opposite direction, I can go to the second box, the same number of turns per minute, but this time I tell the controller to move 24 steps backwards in the anti-clockwise direction. Now I check this box, release it, set original position to 0. Now see what happens. Forwards, backwards, forwards, backwards, forwards, backwards, forwards, backwards. It's not so precise, but at least it moves 24 steps backwards, forwards, backwards, forwards, backwards. So the next step is I would like to develop a simple program that is going to turn the shaft in the clockwise direction and also in the anti-clockwise direction. And if I want to develop software, I use a program called mcDSA-E4. So I'll call this program mcDSA-E4, and a window is open. I close this window there. In order to develop a program, you use this button here, Python script. For the moment, we shall leave the CAN monitor, what it is used for, terminal, what is used for, configuration, what is used for. I think your technical supporter would be in a position to explain and use that with you, but for this moment I'll only be using this Python script. So I open the Python script. I have already developed a simple program. Now, in order to develop the program, you need the settings of the drive that we did previously. Remember, I saved those settings here in the trial file. So if I click on it, it has to open. No, it can't open this way. I have to use the Python script interface to open the trial files, but I don't want to do it this time. So this is the settings that I did previously, and I have saved it here. Now the next step is I call a header file called mcDSA import, and import time. This is a normal header file from Python. The next line is an object on the ID number of the controller, which is 1. So here you have mc.dsa import all these header files. Take it as it is here. I'm importing the or I would like to recognize the type of controller. If I want to drive several controllers or several motors, then I have to indicate every single controller here. So for example, if I have 2 or 3 controllers, they will have different ID numbers. Let me copy this one. And paste it here. I won't have a second controller with the same ID number, but it should be a different ID number, number 2, and so on and so on. So that is how it is made. Now I leave this space as it is irrelevant, and also this space, it might also not be so relevant. What is relevant is here after the while command. Everybody who knows about programming will know what while means. It is a loop, an indefinite loop. First command here, what I'm doing is I'm telling the controller to turn 100 turns per minute, number of turns. And then the second line, I like to explain what this command means. d.sw write means I want to write a command into a memory in the controller. The first command is the index. The second command is the subindex, and the third command is the value. Now the second line, it is the same, but this time I have a different subindex, and I'm telling the controller to move 48 steps clockwise. Then the third line, I have my index and subindex and the 77 hexadecimal value. That is the code of a relative command. Then I tell the program to tell me which position it is if it moves relative position 48 steps forwards. This is the command that I will get a feedback from the controller, and then I delay before the beginning of the next step for 2 seconds. That is very, very important, because if you don't have this command here, if you begin to execute the program, it will just jump to the last command and you won't see anything. Then the next step is I want to turn the shaft in the opposite direction, which means the anti-clockwise direction. And it's the same command here. I want 100 revolutions per minute, turns per minute. This time I want the shaft to turn minus 48 steps backwards. And then I have here the 0xf7. This command means I want to repeat the relative command. It's a repetition of the relative command. If the command is executed, I want a feedback of what the current position is, and then delay it for another 2 seconds, then go back again to the beginning of the loop. So let's start it and see what happens. Before I start, I would like to stop the program that was running previously, and then look up in the picture whether it's working. So it begins to work, it's turning, so it's an indefinite command. It will turn and turn and turn and turn. At every turn, I receive the current position of the shaft. From 0 to 47, you calculate for yourself how many steps are involved. So this is a program. It's a simple program that I have written. I might insert the current program on my YouTube site so that you can download it and then test it for yourself, or you can look it up here. You can look it up here and then copy it down, pause, copy it down, move a little bit downwards, pause, copy it or write it, then move to the next command, pause and write it and execute it. It will work very well. Now my next project will be, I would like to see how to drive the controller in the motor with a tablet. Is it possible? I say yes, it is possible. So that is my next project, to use a tablet with an Android operating system or a Windows Phone operating system or an iOS from Apple to drive the this motor and the controller. That is, I would like to begin with remotely trying to do the same settings as I did with the PC with a tablet. It is possible with a tablet of this size. Maybe you can also try it with a normal smartphone. What I have here is a Windows phone, so I want to try it with the Android operating system, and then also try it with the Windows phone operating system. So that would be my next project. So let me write some few comments here. Pause for 2 seconds. Save it.